Good morning. I welcome you to this session of Python programming. In today's session, we'll discuss about the various modules, the inbuilt modules which are available in Python. So I'll be discussing a few modules. There are many modules in Python. I'll be discussing with you the math module, the sys module, the matplotlib module, CSV module, CX underscore Oracle module, and the scikit-learn module. There are many other modules which you can explore. Uh, and in my previous lecture on modules, I discussed that module is simply any .py file in Python, which can be executed by either by using the import, that is once per session, or by using the reload statement. So let's begin today's lecture with the math module. It's a standard module in Python, and obviously once imported, it is always available. To use it, you need to write the command import math. So import math gives you an access to the underlying C library functions. That means this math module contains the connects you to the C library. And there are many mathematical functions. You must have covered them in languages like C, C++ also. The working of these functions is similar here. There is a ceil function, a floor function, exp function, log x, that is to the natural log, then log x to some base, square root function is there. So let's discuss these functions one by one. I'll be switching between the Python interpreter and this PPT to discuss the various functions available in the math module. So let's go to the Python interpreter and let's begin here by importing the math module. Now once it is available, you can try the certain functions that we have already discussed in the presentation. So there is a math.pow. So if you write here 2 to the power 4 would return 16. It's returning a double value. You can see 16.0 it returns. Math.ceil. So obviously ceil is a ceiling function and floor is a floor function. So this will return a value as 4. And if you use this as math.floor, obviously it will return 3. Math.exp 1. That would simply means e raised to power 1, and e, as we know, has a value 2.7183. So it will return 2.718. Like it gives you a large list of decimal points. And similarly, you can write here the factorial is also inbuilt here. Factorial of 4 would give you 24 as the answer. Similarly, we can try the fabs function, the modulus function. So math.fabs, say if I give minus 34.5, would it, yeah, there's some problem here, math dot. So it will remove the negative sign from the output. And similar is the fmod function, which is used to return the remainder after integer division. So 23 and 5. So obviously the answer would be 3. Okay. And then there is this GCD function, that is the greatest common divisor. So math.gcd, say 24 comma 16. So what would be the answer, guys? So 8 is the greatest common divisor, which divides 24 and 16 both. Okay. Then we can have a mod f function. Let's see what this mod f function does. So if I give a number here like this mod f function would give me the fractional and the integer part and would return it as a tuple. Tuple is like an array, somewhat similar and somewhat different. So we will discuss tuples at appropriate times, but this mod f function returns the integer and the fractional part separated and output in the form of a tuple. So if I try to assign it to some variable, say a, and if I would like to see the type of a, it will tell you that it is a tuple. And you can see while I use this 24.6789, the fractional part is the first thing that is returned, and the integer part, or the other part without the fractions, is returned as a float number. So 24.0 is the integer part and this is the fractional part. That is how the moddef function works. Okay, and we can also see here tuple just like an array. So if I try to print A0, then this is printed. If I try to print A1, then this is printed. The difference between array and tuple, or list as it is known in Python, is that list can be assigned values, but tuple cannot be assigned values. So if I try to change the value of this A0 to say 0.567, it won't allow me because tuple object does not support item assignment. Well, we'll discuss all these concepts of tuples and lists in detail whenever the appropriate session would come. So let's continue with our discussion of mathematical functions. There is a copy sign function you can use. So I can use math.copy sign, which takes two arguments, and it returns the first argument and with the sign of the second argument. So if I write math.copy sign 23 comma -1, it would return -23, as you can see. Okay, and then let's work with the log function. So math.log and say math.exp1. So I'm trying to return the log of 2.7183. That is natural log of 2.7183. And natural log has got the base also as 2.7183. So it will return 1 as the answer. Okay. And if I try to see the log of say 100 to the base 100, would return 1. Okay, and otherwise if I return math dot log say 10, so that would be to the natural log, so the answer would be 2.3025. Okay, and similarly is the sine and the cosine functions, the trigonometric functions. Math dot sine, say if I write here sine 90, you would be tempted that the output would be 1, but the output is not 1 here. Because in Python mathematical functions, you need to specify the argument in radians. Okay, so 90 degrees, you must first convert it to radians. So you can convert it like math.sine 90 star, then you need to multiply it by pi by 180. So math.pi slash 180. So this will return the sine 90 as answer as 1. Similar would be the functioning of the other trigonometric functions. One important function is the square root function, which you all are aware of. So square root of say 64 would return as 8. Okay, so that was about math module. You can work out with the various functions of math module. Now let us discuss the sys module. There is a sys module in Python also. The sys module is a standard module and it provides information about the constants, functions and methods of the Python interpreter. So sys module gives you the information about the Python interpreter. For example, directory system gives a summary of the available constants, functions and methods. So let's try this directory system. Yeah, but first we must import it. And then we can use this directory sys. So it will give you all the the details about the system that we are using. And another important one would be the help sys function. So you can use this help sys also, which would give you a lot of detail. The long description is there. So there is a squeeze text of 354 lines. I can double click on this to see what it has returned. So it will tell me everything that is available in the sys module. So if you need to look for some description of certain methods, constants or values in sys, then you can use this help sys. Okay, and at any time you can just quit from this. Okay, and then there would be a platform you can check you're working on with sys.platform. Okay, so tells you that you're working on a Win32 platform. Then you can see the window version, sys.winver. So tells you it's Python 3.7 and version is Windows 32. Okay, and then there is a version command which is very interesting. So we can just see what this version command is. So sys.version, see the what it has returned. First, it has told us about the Python version, and then it has told us that this is a 32-bit Intel Windows software. And then we can try another level of this with the sys.version underscore info. Okay, so it returns the Python version. And see, in any operating system or in any application software, there is a major version number and there is a minor version number. So the major version number here is 3 and the minor version number is 3. There is another version number which is a micro version number. Now what this version number means, now if there are major changes in, the two releases of a software, then the major version number changes. If there are minor changes, then the minor version number changes. And if a few more details are added to a new release, then the micro number changes. So Python 2.x and Python 3.x are, totally different softwares. Whereas Python 3.5, 3.6, 3.7 would have some changes in them. That is how you see these version numbers. Okay. Then you can see this matplotlib module. So this is for plotting of various plots. Now if you want to plot the bar plots, the histograms, the bar charts, the pie charts, and we need to analyze the data in the shape of graphs or plots, then we can take the help of matplotlib module. Then another interesting module is the CSV module. It is used for analysis of data. CSV stands for comma separated value files, and is a very common extension for huge big files which are being generated because of the online transactions and other transactions. To analyze those files, Python gives us a very interesting module known as the CSV module. It is inbuilt, whereas matplotlib you need to install. Similarly, cx_oracle module is if you want your Python to connect with the Oracle, that is to connect to a database. You need cx_oracle module, and this module of course needs to be installed. It is not inbuilt into Python. Then there is another interesting module known as the scikit-learn module. This module is for machine learning concept and contains a vast number of functions which you can use to carry out your machine learning algorithms. So that is all in today's lecture. And in my next lecture, I'll be discussing the concept of operators with you. A very interesting and a very, important concept. If you need to write good programs, you must be very well aware of the concept of operators. So thank you very much, and more to come in next lecture. Thank you very much.